The title of this unit is Glacial Types, Movement and Their Work, Erosion, Transportation and Deposition, and the various landforms formed by the glacier. In this session, we will be dealing with glacial processes operated in the high latitudes such as Norway, Greenland, and high altitudes such as in case of Himalayas and Alp mountains, played a very significant role in shaping the present day landforms. Besides, the Pleistocene glacial period has left its imprint on the several hundred square kilometers in North America and Europe. The high latitudes and high altitudes are known for very cold climate. Some of our finest mountain scenery to a large degree is a product of glacial geomorphic processes. The glacial landscape has promoted tourism because of its scenic beauty, as in case of Switzerland in Alps mountain and Jammu and Kashmir in Himalayas. In this lesson, let us try to know about what is a glacier, how the glacial process operates, and the landscape associated with it. Let us take a virtual tour to the glacial landscape, keeping in view these objectives as to understand the process of movement of the glacier, to know about the work of the glacier and the mechanism of glacial process, to study the formation of various glacial depositional landforms, to study about various glaciofluvial landforms and how they are produced. Now let us try to understand what is a glacier. A glacier is a moving mass of ice. It can be considered as a river of ice, but the velocity of its movement is very slow. In other words, moving mass of ice downslope under the impact of gravity is called as glacier. Glacier is an extensive mass of ice which shows evidence of downslope movement under the influence of gravity. The movement of the glacier is very slow. Glacier originates in areas where the precipitation is mostly in the form of snowfall. Polar ice caps and high mountainous areas are the major source regions of the glaciers. Glaciers are formed due to the accumulation of ice above the snow line. Snow line. The altitude which delimits the lower level of the permanent snow is known as snow line. The snow line varies in altitude according to latitude. For example, mountains located in the tropical latitude or region, the snow line may be formed at an altitude of 5,000 meters. In mid-latitudes like European Alp mountains, it is located around 2,700 meters. In Greenland at 600 meters, whereas in the polar region it is seen at the sea level. Snowfields. The areas of accumulation of huge amount of ice are called as snowfields. The areas located above the snow line are called as snowfields. All the glaciers are derived from the snowfield. Formation of a glacier. The source of glacier is snowfall. The snow has less density, but when it undergoes compaction, gradually changing its density to become neve, that is firn, and eventually transforms into crystalline form, and thus firn is converted into ice. As the snow compacts and turns into granular ice, and then it is compressed by the overlying layers into hard crystalline ice. Glacial originate in the snow fields through the transformation of snow into compact ice of glacier. Types of glacier. Glaciers exhibit many variations in form, size and location. Different names have been applied to individual glacier type. A more detailed and morphological classification is given, but here only commonly used glacial types are discussed, such as 1. Continental glacial, 2. Valley glacial and 3. The Piedmont glacier. The continental glacial. The continental glaciers are extensive ice sheets and occupy several hundred kilometers of surface. They are called as continental because they are very large and cover most of the parts of the continent. At present, two largest continental glaciers are existing, one in the northern hemisphere and another in the southern hemisphere. That is Greenland continental glacier in the northern hemisphere and Antarctica continental glacier in the southern hemisphere. The difference between ice cap and ice sheet is that of areal extent. That is, ice caps are smaller than the ice sheets. Smaller ice caps occur in Arctic, Canada, Iceland and Norway, etc. Valley or mountain glaciers. These glaciers descend down from the mountain tops and flow or moves down in the valleys. The body of ice moving down the slope under the impact of gravity through the valley is called as mountain or valley glacier. Such glaciers are also called as alpine glaciers. They are located generally above the snow line and they are ablated while descending down the snow line. The important glaciers of the Himalayan regions are 𝗧𝗧 Glacier, Baltaro Glacial, Siachen Glacial, etc. Piedmont glaciers. The glaciers formed due to the coalescence of several mountain or valley glaciers at the foothill zone are called as Piedmont glaciers. Such glaciers are found only in colder areas and not in the tropical or temperate regions because they melt when they reach the foothill zone. Malaspina Glacier of Alaska is the typical example of Piedmont Glacier. The movement of the glacier is under the impact of the force of gravity, which is the result of thickness of the ice mass. The rate of the movement of the glacier depends on the thickness of the glacial ice and the slope. Steeper the slope, faster is the movement of the glacier, and the vice versa. The rate of the movement of the glacial ice decreases from the center line towards the side or edges of the glacier because of the friction of the ice against the rock walls, retards the flow from the surface towards the bottom or the bed. The center of the glacier moves faster than the sides, and that the rate of movement is slower in source region and its terminal parts. The rate of movement of the various glaciers varies a great deal from one to another. The rate of movement of the glacier is more in summer than in winter. Glaciers originating from large accumulation areas descending the steep mountain slope moves even faster. The average velocity of most of the glacier ranges from 3 meters to 300 meters per year. The internal deformation of ice makes the glacier sluggish in their movement. For example, the 𝗵𝗱 Glacier in Victoria Land of Antarctica moves at a rate of 3 to 4 meters per year. Some glaciers experience short phases of exceptionally rapid advance of ice margins, leading to a great increase in forward velocities. Such phases of rapid advance of glaciers are called as glacial surges. Generally, a surge is triggered by thick accumulation of ice leading to melting of the basal layer due to the pressure overlying the mass. Once the surge begins, the increased velocity of the ice movement further increases the rate of melting and the process is accelerated. The forward movement of the glacier is called as advance of the glacier, while the withdrawal of the glacier is known as retreat of the glacier. The destruction of the glacial front due to the melting of ice consequent upon the increase of temperature is called as ablation of glacier. Ablation thus means the loss of ice by the melting or evaporation. Now let us discuss the work of a glacier. Like running water, a glacier also performs the work of 1. Erosion, 2. Transportation and 3. Deposition. Now let us see what is the erosional work of the glacier. The erosional work by a glacier is carried out through 1. Aberration and 2. Plucking or quarrying. Glacier, which is an ice mass, is geomorphologically inactive, but when weathered coarse rock debris is carried by the glacier at the base, it becomes active agent of erosion. Aberration. Aberration results primarily due to the presence of rock fragments which are the product of frost wedging embedded in the basal ice. These rock fragments polished, scratch and cut grooves on the rock surface over which glacier moves. Size of the debris carried by the basal ice of the glacier determines the type of aberration. If the debris comprises sand and other small particles, the surface becomes polished. On the other hand, if the debris comprises of gravel and rock fragments, the surface will get striated or grooved. The glacial striation are numerous scratches that are formed by the angular rock fragments dragged across the rock surface by moving glacier. Thus, the glacier erodes its bed and side walls with the help of tools of erosion, that is coarse debris, through the mechanism of aberration. Plucking. Plucking or quarrying involves joint block removal. Plucking is important in areas with well-jointed rocks, in the areas where blocks of rocks have been already loosened by frost wedging. Plucking produces characteristically shattered and broken appearance to the landscape. Sapping is the breakup of rocks by alternate freezing and thawing of water at the bottom of cracks between the glacier and the side and floor of the valley. Transportation work of the glacier. The rock debris carried by the glaciers is collectively called as glacial drifts. Glacial debris is divided into 3 types on the basis of location as 1. Englacial debris, which is transported within the glacier. Supraglacial debris, which exists on the surface of the glacier. Subglacial deposits, which is found at the base of the glacier. Glacial sediments are transported along the sides, floor and snout of the glacier. The debris falling directly into the glacier is transported without touching the bottom of the glacier. The debris falling on the surface of the glacier is transported downslope along the moving ice mass. The materials derived from the bed by subglacial erosion are transported by touching the bottom. 3. The depositional work of the glacier. The depositional work of the glacier is related to the deposition or settling down of glacial drift transported by the glacier. Deposition will take place mostly where the glacier melts. Areas covered by continental glaciers will have unassorted or unstratified deposits called as till or boulder clay. When the glacier melts, streams emerging from the snout of the glacier undertake deposition, which is stratified in nature. These deposits are called as fluvio-glacial deposits. Depositional landforms. The depositional landforms in the glaciated landscape can be divided into two types. 1. Glacial deposits and 2. Glaciofluvial deposits. Now let us discuss about the glacial deposits. The deposited material directly by the glacier is not sorted. Glacial deposits are heterogeneous in composition and lacks stratification. Such deposits are called as glacial till or moraines. The landforms associated with the glacial deposits are 1. Moraines, 2. Till plains and 3. drumlins. Moraines. Moraines and the till plains constitute the most widespread glacial deposits. Moraines are glacial deposits made up of different size, shapes, which includes boulders, rock fragments, pebbles, sand and clay deposited by the glacier or the ice sheet. Depending on the location, moraines can be classified as 1. Lateral moraine, 2. Medial moraine, 3. Terminal moraine, 4. Ground moraine and 5th the recessional moraine. Now let us see what is a lateral moraine. Lateral moraines are parallel ridges of till on the either side of the glacier. They are formed due to the deposition of sediments along the margins of the glacier when it contracts in size due to melting of ice. Lateral moraines are generally long, narrow and steep-sided ridges parallel to the glacial valleys. Medial moraines. Medial moraines are formed due to the deposition of glacial sediments along the internal margins of two glaciers. Terminal moraines. Terminal moraines are the glacial deposits that occur at a point where the glacier melts. Terminal moraines are crescentic shaped mounds of debris. Terminal moraines are the long ridges of deposit located at the end of the glacier. Terminal moraines are also called as end moraines. They are formed due to the deposition of glacial till at the snout of the glacier after the ablation of ice. The recession of the glacier or the ice sheets result in the deposition of several ridges of or mounds in the basins. Such landscape is called as knob and basin topography. Ground moraines. Ground moraine is the load carried by the glacier and is deposited on its own bed. or the base. This happens when the lower part of the ice becomes so heavily charged with sediments that it cannot transport it and therefore deposit it in the form of ground moraine. Ground moraines are formed when the glacial sediments or till are deposited at the floor of the glacial valley. The sediments are not sorted because coarse and fine sediments are deposited together. Recessional moraine. If the mouth of the glacier does not stabilize at a place for a long time but goes on retreating, the terminal moraines are formed during each retreat of the glacier. When the glacier retreats and halts for a period of time, it leads to the formation of successive terminal moraines, which are known as recessional moraines. The succession of terminal moraines is called as recessional moraines. Till plains. Till is the mixture of sand, silt, clay, pebbles and large boulders. A till plain deposits tend to hide the irregularities on the bedrock surface. The till deposits are thus thicker in depressed areas and thinner in upland areas. Deposition of ground moraine by the continental glaciers cover vast areas to form till plains. A greater part of the till may be derived from the bedrock in nearby areas. However, large boulders occasionally differ in character from the bedrock upon which they are deposited. Such rock fragments are called as erratics. Erratics is a rock that has been transported by the glacier and deposited in areas of dissimilar rock type. Group of erratic blocks having a fan-shaped distribution from their source are called as boulder trains. Drumlins. Glacial deposits which are egg-shaped or spoon-shaped or oval or elongated ridge-like feature or small rounded hills found in the till plains are called as drumlins. They consist of unstratified till, but some have stratified water-laid deposits. As the glacier starts melting, large quantity of materials are deposited in the shape of inverted boat. The slope of the drumlins is steep towards the snout or the front portion of the glacier and gentle towards the downstream direction. The long axis of the drumlin are parallel to the direction of the ice movement. The long axis of the drumlins give an indication of the direction of the glacial movement. Drumlins are generally found in large groups. The glacial deposits in the form of egg-shaped drumlins are seen in the U-shaped glaciated valley, which resembles a basket. The topography that is evolved by drumlins in the glaciated valleys is called as egg and basket topography. Glaciofluvial deposits. The glacier starts melting due to increase in temperature when it descends below the snow line. The process of melting of the glacier is called as ablation. Meltwater from the glacier flows through small temporary streams. These streams carry sediments for a longer distance and deposit them in various topographical forms. The deposition of sediments after the melting of the glacier is called as glaciofluvial deposits, and the landforms resulting from such deposits are called as glaciofluvial landforms. The main characteristics of the glaciofluvial deposits is that it has been sorted and stratified into layers by the melted channel of water from the glacier. The glaciofluvial landforms includes eskers, 𝗬𝗓s and 𝗬𝗓 terraces, outwash plains. Eskers. Eskers are long, narrow and sinus ridges of sand and gravel and mostly situated in the zone of ground moraine. The sides of the eskers are very steep. They vary in height and width ranging from few meters and extends for kilometers in length, parallel to the direction of the glacial movement. Eskers are more characteristic of continental glaciers. Due to the melting of glaciers at the bottom of the glacier, a long but narrow water channels are formed below the surface of the glacier. The sediments carried by these subglacial channels, when obstructed, deposits the sediments to form eskers. Sometimes a series of swellings of deposits are strung along the eskers at regular intervals. Such eskers are called as beaded eskers. 𝗬𝗓s and 𝗬𝗓 terraces. 𝗬𝗓s are small rounded hills or mounds of sand and gravel which is deposited by the melt water. They represent fillings made in the crevices or depressions at or near the margin of the glacier. 𝗬𝗓s are considered as small alluvial cones if deposited on the land, or small alluvial deltas if deposited in the lakes. So, 𝗬𝗓s are classified into cone 𝗬𝗓s and delta 𝗬𝗓s. 𝗬𝗓 terraces are formed in the areas between the side of the glacier and the valley walls. Narrow flat top terraces like ridges are formed along the trough between the glacier and the valley sides are called as 𝗬𝗓 terraces. Outwash plain. The glaciofluvial depositional plain, which is composed of materials washed out beyond the terminal moraine, is called as outwash plain. The melted channel of water spreads like sheet of water and erodes the sediments in front of the terminal moraine and thus forms a plain called as outwash plain. Outwash plains are characterized by clear-cut sorting or stratification of sediments. The coarser sediments are deposited first, followed by the finer sediments. Outwash plains are also known as Sandur Iceland. The outwash plain deposits in the form of sand and gravel extending down the valley are termed as valley trains. Now, conclusion. In this lesson, we tried to know about the concept of snow line and snow field, which are the source region of glaciers. Glaciers are found in the high mountainous areas in the form of valley or Piedmont glaciers, whereas near the polar regions, they are in the form of continental glaciers. The erosional work by the glaciers is mostly undertaken by the process of aberration and plucking. The glacial deposits are of two types, one the glacier and the other one is fluvio-glacial deposits. A moraine, till and drumlin constitutes the glacial deposits, whereas eskers, 𝗬𝗓s and outwash plains are the glaciofluvial deposits. In the next session, we will be mostly discussing about the erosional landforms as produced by the glaciers.